So you can have nested loops, loops within a loop. I think we did an example of that. Tell me we did, right?
Nested loops?
Nested loops?
Yeah, we done it.
Okay, so we're going to do one more example, and then we're going to get off that topic. So we're on chapter 5. So what I want to do is I want to make a multiplication table that looks like this. Don't type this because I'm going to erase it. Right. I'm just showing you what kind of output I want. It's going to be spaced out larger than that. But 2 times 2 is 4. 2 times 3 is 6. Right. 2 times 4 is 8. 2 times 5 is 10. And so on. You know, 4 times 3 is 12. 4 times 5 is 20. That's what I want to do. So I'm going to use a nested loop. One loop, the inner loop, is going to print numbers horizontally. And then when it's done printing numbers horizontally, it's going to go down to the next line, and so that's the outer loop. And so I want to go from 1 to 5, and I want to do it in as short of syntax as possible. So I'm not going to use while, because if I use while, it takes like 4 statements to get it going. And if I use a for loop, it takes fewer, because I don't have to initialize the value and then check it on a separate line, and then update it on a third. So here we go. For COL, for column. Now in some languages, it would look like this. Don't type it. Equals 1 to 5. Don't type that because that's the Visual Basic programming language, or some variant of it. Instead, ours looks like this. For column, for call, in range, starting at 1 and ending before you get to 6, and going up by 1. In parentheses, colon. And then for row in range, same business. 1, comma, 6, comma, 1. Now this is just a multiplication table for 5 by 5. If we wanted to make it 10 by 10, we would change that 6 to an 11, because it would mean start at 1 and go and stop before it hits 11. Now I understand that if it's counting to 5, you'd love to put a 5 there. Me too. What it's doing is it's pretending it's got a less than there, while column is less than 6, rather than less than or equal to. So that's why we got to go one beyond where we really want to go. And so for range, parentheses 1, comma, 6, comma, 1, in parentheses, colon. And then we're going to print row times column. And then let's just put a tab in there to space it out. There's more sophisticated ways of spacing things out, but a tab is good enough. So a quote, not a bar, a quote, and a backslash, the one above the enter key, T, end quote. Now here's where things get a little bit weird. I'm going to go ahead and leave it as a mistake, but I'm going to put a comment here to flag it that I'm coming back to fix it. All right, and now I can add my end for by back indenting 1, and I can add another end for by back indenting 2. All righty. What lecture are we on anyways? I've lost track. Are we on J? All righty. Run customized. I didn't used to have that option there. Is that anybody else getting that one? Run customized? Is that an option for y'all? Brand new for me. All right. Never seen it before in my life. Been using Python for quite a few years. Run module. Okay. Well, that's not our multiplication table. The problem is it's going to the next line every single time, just like if you're using a typewriter and you hit the enter key. The print statement does that by default, but we can tell the print statement we don't want it to go. We don't want it to go to the next line. So after the /t, we're going to modify it to tell it don't go to the next line. So I deleted the parentheses. It's going to show up in a minute again. But right after the end quote comma, we need to add an end parameter. end equals, and I need to put like a quote in parentheses. And what that means is instead of doing a new line, instead of doing a /n automatically, just print nothing. That prevents it from going to the next line every single time. So end equals quote in parentheses. All right, that's halfway there. But if I run it now, well, it's not looking too good. What's it doing now? Now it's not hitting enter at all. Now it's printing 1, 2, 3, 4, 5, 2, 4, 6. So I need to get it to go to the next line after it's done printing out an entire set of columns. You know what? I goofed those variables. The outer loop is the rows. The inner loops are the columns. The logic doesn't need to change much. It would work the same, but the variable names being wrong bugs me. So I'm going to change COL to row, and I'm going to change row to COL. This is the outer loop, row by row. This is the inner loop, column by column. And when we hit the last column, we want it to go to the next line. So I'm going to hit enter there and a back tab so that it's indented only one level. And I'm just going to add a print statement to make it go to the next line after all the columns have been printed out. And now it'll have our multiplication table. I'm going to keep hitting that I'm so used to going down for the bottom option. I have to take care. All right, there we go.
Bless you.
Bless you. You know, there were user interface guidelines, design guidelines when people first started making graphical user interfaces. And one of the guidelines was that things are easier to hit if they're at the edge of the screen because you can just whap your mouse up and then click on something. Whereas if it's not at the top of the screen, you have to move more carefully. But then when floating windows were introduced, you know, that rule kind of went by the wayside. But that's why, you know, this is down here. It's really easy to slam to the bottom. But nowadays that people have gigantic monitors with, you know, 8,000 by 10,000 pixels, it takes a huge amount of time to scroll down there. But anyways, if you think about it, user interface guidelines, nah, I'm not going to even go off on that tangent. All right, so that's our example of a nested loop. We've done 2 of them now. One of them was kind of like a clock, where it was updating the minutes and then updating the hours. That may not have been the precise example, but you remember seeing that. Any questions? Kathy, come in. You here now?
Yeah.
All right. I need to update the attendance. Want to make sure. Okay. Count everybody. So if we were going to flowchart our nested loop, if you feel like drawing it, that's cool. If you don't, that's fine. I'm going to draw it. It's just going to have 2 levels of indentation. All right, I made a mistake by not logging in with my educational account. So if I was going to do a good job, I would copy the code and paste it in a little text box. And like I said, it's okay if you skip this. One fewer thing to upload. On the other hand, if you like to have it in your notes, that's cool. And then I need to put that against the left margin. All right, now we're good to go. I could boost the size of it, right? Make it a little bit easier to read. Maybe that's too easy to read. Alrighty. So I am going to make a complete flowchart. So I'm going to stick my start on it. Maybe just underneath it. And then I have a for loop. We represent for loops of the same shape as ifs. And then inside the for loop, indented inside it, we have another. So I'm going to draw another diamond. I'll go back in and fix some text in a minute. Just kind of getting the shape right. And so the first one we said was for row. Now the book's going to show this different, but I'm just going to do it in pure Python. Because the way the book shows it, well, I don't think the book shows for loops. I think they show while loops. So, for row in range, parentheses 1, 6, 1. And it's kind of tacky to be putting pure real lines of code here rather than some kind of pseudocode. But like I said, the book shows while loops instead of for loops. So we're going to go with that. And then the next one was for column. For column, COL, in range 1, 6, 1. Now in the Python language, that third parameter is optional. You could leave it off and just make it 1, 6, and it's going to assume that it's counting by 1. But I like to leave it there because if I wanted to suddenly start making it count by 2s or 4s or 8s, I know what to change. I change that last number. Okay, and indented in here is an output statement or a print statement. So it's a print, so it goes in a tilted. So print or output, row times column. And that's good enough, but I might want to represent that it's not going to the next line. I'm going to leave that alone because that's not the biggest part of the logic. And then we're going to loop back because we're done with our loop. If we go back and look at our code here, right? That's the only line that's in here. And then we have another print here that's indented under that for, so it's going to be right down here. Output new line, something like that. Or print, if I just wanted to put the Python, I could do that. I should have added that as a comment as to why we had an empty print statement, because this is what it's doing. And as a matter of fact, I'm going to go back to my Python and put a comment there explaining what that empty print statement was. And that's it. This guy needs to loop back as well. And again, remember that I show y'all a slightly different way of doing this. They make their loops go back above it. If you wanted to make your loops go back above it, you could do that. I think it makes it harder to read. But that's about what it would look like there. And then this one would arc off over there. I think it's easier if it goes like that. Alright, and now we're done. So we just need a stop. I could make this go straight down and put it at the bottom, but just to get it all on one screen for y'all to see, I'm going to leave it there. Yeah, maybe there's room. Here we go. There it is. You can tell it's a nested loop because we have an outer loop and we have an inner loop. Just like nested if statements. You could have an if here and an if here. Or you could have a for and an if, or an if and a for, right? You can nest loops inside of decisions and vice versa. By the time you start indenting like more than 3 or 4 levels, the logic is getting a little bit too convoluted. And you ought to think of a way to break it up into functions, which we haven't done a lot of yet. And by functions, the book calls them modules.
So with for, are you saying that there's going to be 2 decision blocks? Like,
Why do we have 2 decision blocks? Because our code had 2 for statements. If we only had 1, then there wouldn't have been this one inside here. If we had a for and a for and a for all indented, then we would have jutted off a 3rd column. Does that make sense? Feel free to say no.
yeah, I mean, it makes sense.
Okay, okay, cool. So the drawing makes pretty clear that the inner loop completes. It does every iteration of the inner loop, and an iteration is one complete pass through the inner loop before it goes back and does one more of the outer loop. So it prints out all those numbers in a row, all the columns in a row, and then it hits the return key. And then it does the inner loop again, does one more iteration of the outer loop, which is to hit the enter key to print out a new line, and so on. So that's why it says nested loops never overlap. The inner loop is always completely contained within the outer loop, just like we drew here. Inner loop is completely contained here. The inner loop goes through all of its iterations, our fancy word. Each time the outer loop goes through one iteration. The total number of iterations is equal to the number of inner loop times the number of outer loop. That's a point worth making. If this is counting from 1 to 5, that's 5 iterations. If this one's counting from 1 to 5, that's 5 iterations. 5 times 5 is 25. And if we look at our output, that's how many bits we have here, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and if we multiply those two together, we'd see that we have 25 data elements being printed out. So that's probably worth actually commenting, and I promised myself that I was going to go and put a comment here. Go to the next line. That was the point of that one. So the total number of iterations equals the number of, this is a long way of writing it, the number of iterations of the outer multiplied by the number of iterations of the inner loop. In our example, 5 times 5 equals 5 times 5 equals 25. And now I wish I'd explained what 1, 6, 1 did. I wish that I'd put that as a comment, but I already have a comment there. So I guess I'm just going to add on another comment down here, and we're getting a bunch of comments. I probably should have started the green text. For row in range 1, 6, 1 counts from 1 to 5 by ones. And I hope you understand what I mean by ones.
1, 6, 1, 5.
Thank you for catching my error. Darp. There we go. So if I change that to 2, it would count by 2s. So it would do 1, 3, 5. I could prove that. I don't know why I would want a multiplication table with only odd numbers, but that's what I'm going to get. I think I'm just going to start hitting F5. Y'all watching at home, that's how it's magically running. I'm just hitting F5. Alright, and there, it only printed out the odd numbers. I'm going to change that back. As I said, you can leave off the second number and it defaults to going by ones. Don't make that change. I like leaving the second number there so that we can change it easily. But it behaved the same way. If you leave off the first number after you've left off the last number, it behaves a little bit differently. It doesn't start at 1. And since we didn't tell it where to start, it starts at 0. So that's why our multiplication table starts as zeros. Not real useful because 0 times 0 is 0. In fact, that looks pretty dang dumb. So I'm going to change it back to the way it was. 1, 6, 1. 1, 6, 1. But you could start it at another number. Let's start at 20 and go up to 100 counting by tens. 20, 40, or 20, 30, 40, 50, 60. So for x in range, I want my first number to be a 20. And I want it to stop at 100, so I'm going to go 1 past 100. Because the loop means, the range statement means, stop it before it hits 101. Keep going while x is less than 101. And then I want it to increment by 10 each time. And so that's going to print 20, 30, 40, 50, all the way out to 100. And then let's just put a print statement inside here. Print x in parentheses. Look at that, I misspelled iterations. Got to find a way of removing that. All right, there, it went 20, 30, 40, 50, 60, all the way by 100. And we could change this number like to 20s and it would count by 20s. Change it to 50s and it'd print, you know, by 50s, whatever. Maybe you see why I just put the Python in the flowchart. How would I represent that starting at 20, going to 100 by tens? I would have to use some kind of language, some kind of computer-use language. I'm sure that there's pseudocode for for loops, but it probably looks like the Visual Basic language. Probably looks like for column equals 1 to 5. Don't change your chart, please. Step 1. That's the visual, that's the basic language way of doing it. I kind of like that. That is not how we do it in Python, so I'm not going to stick Visual Basic in the middle of our flowchart. Another way you could do it would be for parentheses, column equals 1, semicolon, again, don't do this, column less than or equal to 5, semicolon, column plus plus. That's how you do it in C++ or Java. Again, you're specifying the starting point, you're specifying an ending point, and you're specifying how much it's going up by. Or you could say plus equals 1, like we do in Python. Now, this is showing 1 and 5 rather than 1 and 6. We could make it say 1 to 6 by just changing this to less than. Like that. And now the syntax is very similar to Python, right? It's got a 1 and a 6 and a 1 there. But that's the Java programming language, which we're not learning. I'm going to undo all that as well. I show you these things and then feel free to delete them from your brain until you actually take that language. And I hope y'all do. I hope all of y'all will enroll in C++ as well as scripting, or enroll in Java. Because y'all are good students. Don't do it. The loop control variable is not initialized. Okay, I didn't draw a loop using a while, and sure enough, if you're going to use a while statement, you have to initialize your variable first. I could revise my flowchart to use while instead of for. I think I won't for now. Maybe I shouldn't have used for because this is just talking about while the whole time. Alrighty, let's do a loop with a while, just to match the book. Just like our minutes counter. We're going to print every 15 minutes, starting at 1, going up, from 1 o'clock to 6 o'clock, right? So it's going to print 1, 1:15, 1:30, 1:45, 2, 2:15, 2:30, 2:45. So we need an hours counter and a minutes counter. Hours equals, I want to start at 1 o'clock. Minutes equals 0 because I want the minutes counter to start at 0, right? 1 hour, 0 minutes, and so on. And then while hours is less than or equal to 6, because I'm going to go 1, 2, 3, 4, 5, and 6 o'clock. The inner loop, while minutes less than or equal to 45, colon. I'm going to print hours, comma, quote, colon, end quote, comma, minutes. Now the output's not going to look pretty. We don't like seeing spaces in our hours and minutes, and since we're using commas, we're going to have spaces. And we like for minutes to always be printed using 2 digits, and this will only print it in 1 digit if it's less than 10. So it's not perfectly formatted, but it's okay.
Why do you, on that print statement,
Yeah.
why do you have the 2 parentheses around that?
Those are quotes.
Why do you have the dots there? Not the quotes, but the...
Here, let's take that out, and I'll show you. Good question. All right, so the inner loop is based on minutes, so we have to update the minutes variable. And I want it to go up by 15 each time. So minutes plus equals 15, end while. And then hours, make sure it's back tabbed, just goes up by 1 each time, plus equals 1, end while. The fastest way of demonstrating why the colon is there is just to leave it out and run it and then put it back in. You'll see the difference. Look at that. I remembered to choose that option rather than that one. Proud of myself. Alright, and so it counted. Oh, look at that. It did not do what I wanted it to do. I wanted it to go all the way out to 6. So I've made some kind of mistake here. Have to go. Look, I have a logic error. Anyways, did you see the way it looks without the colon? But I want it to look more like a clock, where we express time in hours, colon, minutes. So I'm going to go back and modify my print statement so that there's a colon in it. So comma, quote, colon, end quote, comma. Now it's going to be too broadly spaced out, and it's not going to have 2 digits in the minutes column all the time. And this doesn't fix our syntax, our logic error at all, but it'll demonstrate the colon. There. So why in the world is it only counting? I am totally stymied. What if I started hours at 0 and kept going until 3? What's it going to do? Don't make that change. And don't go to sleep while I figure this out. I may have to stop the recording. What in the world are you doing?
After the inner while loop, you could have minutes go back to 0.
Yeah, the minutes are supposed to go back to 0. Oh, you're right. Dude, you get the points. Nothing is resetting minutes back to 0. So about the time that we increment hours by 1, we need to reset minutes. And heck, if we had set minutes equal to 0 right here, we wouldn't have had to worry about it later. So I'm going to cut that line right there. Get rid of minutes is equal to 0. Oh, and I wanted it to start at 1 and go to 6 o'clock. So I'm going to change that back. But then, above that while minutes statement, I'm going to make it say minutes is equal to 0. I'm going to reinitialize it to 0 each time. I'm so happy you spotted that. Now you see why I like for statements better? The for statement handles all of that. It handles initializing it, it handles the limit, and it handles the update. So those 3 lines of code, or those 3 things, are handled in one statement here, but they're handled in 3 here, right? Hours is initialized, hours is compared, hours is updated. The for loop syntax is much cleaner. If you're going to have a counter, you ought to go for the for loop. Did it again. And there goes our clock, counting from 1 o'clock all the way to 6:45. Another example of inner loops done with while statements. So I'm going to go and flowchart that as well. Might be the last flowchart I draw today. If you feel like it, go for it. Excuse me. Okay, this is great. I promise you I'm not sick, but I do have allergies. So there's my code. I'm going to start, and then I have a math statement here that hours equals 1. And then we have a while. We know what a while is. It's a diamond. Where'd my diamond go? Okay. Oh, sure it was there. Inside the diamond it says while hours less than or equal to 6. The book leaves the word while off. Feel free to do it either way. I'm going to hit Shift Enter right here. Put those on 2 separate lines. And of course draw some arrows. You can waste a lot of time when the arrows start suddenly going off in the wrong directions. I'm sure y'all have had that happen. Alright, now I'm going to jut off, and what's the next line? The next line is to set minutes equal to 0. Which is math. If this was pseudocode, I'd stick the word set in front of it. But I'm doing it from Python. I've been leaving that out. Alright, and then under the minutes is another loop. While minutes less than or equal to 45. So that's going to be another diamond. While minutes less than or equal to 45. And again, I'm going to hit Shift Enter in front of the word minutes just to make it look better. I don't care if your words overlap, you know. It's not an art class. We don't have to color within the lines. And what was that nested inside that inner while loop is a print and an update. Print hours, comma minutes, and update the minutes. So output is done in a tilted. Output hours, comma, quote, colon, quote, comma, minutes, and that looks kind of tacky, so I may hit Shift Enter there to kind of break that up. Hit Shift Enter there to kind of break that up. Or I could have stretched the box out, right? Or putting the word print there, since we were starting with Python rather than pseudocode, would have been fine. The next line after that print statement is a what? If I go back to my code, it was an update to minutes. So that's math. Minutes plus equals 45. I'd stick the word set in front of it if I'd been doing pseudocode. Alright, now this loops back to the inner loop. And this one loops back to the outer loop. Oh, by the way, if you hold the space bar down, the arrow turns into a hand so that you can just move around like that. Makes it easy to scroll, especially on laptops. And that's the end of that, so I'm going to draw a stop. And if you wanted to drag the stop down further so that it was underneath, the rest of the code, that'd be cool. You know why I didn't get it all up to fit on one page. You don't have any reason to worry about that. All right. Wave your hand if you still need time because you are drawing this. All right. That's cool.
So is that another example, just using while for a nested loop?
Yep. This is using whiles rather than for, just like our code is showing. The difference is that if you use a for, and sorry guys, I'm going to scroll up for a minute, is you don't have to initialize your variable, right? So there's no math block there, and you don't have to update your variable. Oh, I left something out, guys. What did I leave out? Comparing my pseudocode.
The minutes plus or equals to 2?
Yeah, I didn't update my minutes counter, and I don't even think that I updated my hours counter. Wait, I did update the minutes right there, but I never updated hours. So if I had not done that, it would be an infinite loop. I'm going to go and make that change. I'm going to forget that. Watch what happens if I leave that out. Yeah. See, 1 never changes to 2 if I leave that update out, which in my flowchart I did. So I have to revise my flowchart. I need to find a place to stick that in. It would have gone here. So I'm just going to delete that line, and I apologize. That was not one of those intentional mistakes that I make to teach y'all something. So instead of no going back up to the block, the looping back, it needs to go to a math statement, which says hours plus equals 1. And that can go back to the loop. I'm compressing it as much as possible, and you know why. You don't have to bother. I'm going to pause the recorder for a second. All right, how are we doing on our art? I'll print it out if anybody needs it, because I want to get on. Okay. The most common mistake in writing a while loop is to put something inside the inner loop that belonged in the outer loop. Or just putting something inside of a loop that shouldn't have been there. I'll give you an example of that. Since for loops are the easiest to write, but this could be demonstrated with a while loop as well, right? For x in range, starting at 1, going up to 10. So I'm going to make that 11, incrementing by 1 each time. And say I wanted to create a sum. And I only wanted the sum to be printed once at the end. So I need a sum variable. Unfortunately, sum is a function. It turns purple when I type it, so that's not a good word. So I'm going to choose total instead. So total is equal to 0. For x in range, total plus equals x. Don't put a space there like I accidentally did. Plus equals x, right? We're going to add x to it. When x is 1, we add 1 to our total. And then when x becomes 2, we add 2. And so the total is going to be 1 plus 2 plus 3 plus 4. And if you happen to remember, I took calculus or something, that's called summation. 1 to 10. That's the loop that we've written. In fact, this comment should have been above it all. So I'm going to move it up here. All right. And my requirements were to print the total only at the bottom. Only once. But I'm going to make a mistake. I'm going to leave it indented. So print parentheses quote summation of 1 through 10 equals end quote comma total in parentheses and then end 4. Now it's not going to break. It's not going to blow up the program. It's just not going to only print the total once. It's going to print the total 10 times in a row, which might be interesting, right? But my spec said just print the total once. What if we were going to add up the numbers 1 to 1,000,000? I would not want to see 1,000,000 intermediate totals. And so here it goes. Since I left the print indented, there. And while it's interesting, and if you wrote your code like that, I'm not going to fail you, I might deduct a few points and tell you to revise it. By the way, has anybody turned in a second copy of a program that you did not get full credit for the first time? Alrighty. It's being squirrely about that. So yet again, I'm going to ask for a text message. Please text me telling you what message, what homework you've turned in. You have my text number, right, both of y'all? Tell me if you do. Yeah, okay. So please do. I'm going to have to come up with another way of allowing people to resubmit programs because it's being squirrely, or else I need to learn something new. All right, so what did I do wrong? Since the print statement is inside the loop, it happens every time. And that's not what I want it to do. I want it to only do it once, so it has to be outside the loop. It has to be unindented. And this is a very, very, very common programming error. And it's not because you're dumb. I do it too all the time. Well, you know, maybe I'm dumb. But alrighty. And now my code looks kind of lame because the end for should actually be above the print statement because it's not part of the loop. So I'm going to put it above. And again, these comments are just, you can leave them out. You don't have to have end whiles and end fors. You do on your pseudocode, though. Now it's going to look a lot better. It's going to only print the sum once, which is what I wanted. This is called a running total. To get a running total, you have to declare and initialize your so-called accumulator variable. We always got to make things as complex as possible with the language. Accumulator variable total. Why? Because it's just accumulating values as it goes along. Above the loop, I'm going to actually number these steps. That's step 1. Declare and initialize your accumulator variable above the loop. And then step 2 is inside the loop, modify the accumulator. Parentheses, add to it, if that's your goal. There's another one where you multiply the numbers, like from 1 to 10. Any math fans remember what it's called if you like multiply 1 by 2 by 3 by 4 rather than add them. There's even a key for it on your big complex calculator. It's an exclamation point. It's factorial. All right. And then 3, modify the counter. But I'm just going to leave that out because if you're doing a for loop, the counter happens automatically. The modification, the update. And we see that in our code. Here's we initialize our accumulator. Heck, I could add a comment as to that effect on the total line. Initialize accumulator. And here we're going to update the accumulator. You know, if we just called it the total variable, it'd be easier to type. But that's all right. We want to speak textbook computerese, like computer science majors, so that we can impress our friends and enemies. All right, I'm going to switch over to Canvas for a moment to show you all the flowchart you need. Now, the assignment gives you a big old explanation of what you're doing. You can ignore the big old explanation. It gives you a lot of background. But I'm going to go under modules. There'll be a Dropbox for it in just a second. In fact, I think there already is. But if we scroll down to the assignments page, the homework instructions, there should be, there better be. Wait, where'd you go? If you're not here, I'm going to throw a fit. I swear I uploaded it. All right, everybody gets a 25. Oh, here, sorry. I found it just in time to take that back. Here's the exam 1 flowcharting assignment, and it'll be tagged inside the homework box as normal, so it'll be easy to find. Alrighty. Background. Draw a flowchart that matches the logic of the pseudocode below. And by the way, this is true actually. And in fact, somebody died in a radio contest where you were supposed to drink as much water as possible in order to win a Nintendo Wii. And it's too bad that somebody died trying to win a video game. But the concept, serious consequences, including death, can occur if a large amount of water is drunk over a short period of time. That's an actual, honest to goodness true. And if you are a sports guy, you probably are aware of that. You know, and it's also bad news to not drink enough water. So what happens is there are electrolytes in your blood. You need those electrolytes, right? That's why you drink Gatorade during heavy. But if you get them too diluted, then your brain, your nerves stop working. That's a condition technically known as hyponatremia. When your sodium levels drop, electrolyte's just a fancy word for sodium, and sodium's a fancy word for salt. That's why Gatorade tastes salty. When sodium levels drop below a certain point, the body begins to function poorly. So, this program asks the user for how many gallons of water you're going to drink. over how many hours, and it'll display a warning if it's too much. Now, who thinks ahead like that? Okay, well, you know, I'm going to be working out for 7 hours, so I'm going to drink 2 gallons of water. But whatever. Drinking more than 0.25 gallons per hour could result in health consequences. So according to this, we should only drink a quart per hour. Now, if you exceed that a little bit, it's not going to just like knock you dead, right? But so don't drink more than 1 big gulp an hour. In the second page is a discussion of logic, but you only have to look at the pseudocode to flowchart it. Here's the pseudocode for it. Looks pretty typical. Start. Input gallons, input hours. If we had wanted to, we could add declarations for it, right? I could modify the assignment right now, but since I keep having uploads disappear, I'm not going to do that. And then set the limit to 0.25 because 1/4 gallon per hour is max. Then we're going to calculate the rate. How fast are they drinking? Gallons per hour. And then here's how much they should be drinking, the max. Or how many hours it would take them to drink that. You know, if you're bringing along 2 gallons, it better take you 8 hours to drink that. And so then we're going to print some information. The consumption rate. And then the gallons per hour. And then if the rate is greater than the limit, we say slow down. Take at least this many hours to drink that much. Otherwise, we say, okay, that's safe. So it's just simple pseudocode. Despite the 20 paragraphs explanation up here, even if you don't get it, you know how to flowchart. You know how to do all that. The only nested code is going to be inside this if, and you know how to flowchart if-elses. All right. Yeah. People die from water drinking contests. The average adult's kidney can at max process about a quart an hour. So you really shouldn't drink more than a quart of an hour even if you're inactive. Now, if you're addicted to super big gulps, I don't know what to say. All right. I mean, I am. So, note, sweating uses water. That's enough. Enough explanation. Makes sense, guys? Ought to be an easy 25 points on your exam. If you get stuck, text me about it over the weekend. Take a picture of your flowchart, send it to me. I can mark it up, send it back, right? So really, you're going to get a good grade on it if you just try. All right, let's go for a little 2, 3, 4, 5, 10 more minutes, and then we're going to end class. I'm going to go and add that as a comment here. The big mistake, or the most common mistake, is putting code that should be in the loop outside it, or vice versa. Now, I demonstrated the vice versa. I demonstrated putting code that should be outside it, inside it. Here's the example of going the other way. Oh, wait, I can't go the other way because I used a for loop rather than a while loop. So forget it. I'm not going to demonstrate that. If you ever have an infinite loop, it's because, most likely, you unindented your update to the variable. I could demonstrate that with our clock counter. Not gonna, though. But just imagine if we didn't update the hours. You know, so we put the update for the hours completely unindented, so it wasn't inside the loop at all. It would repeat forever because hours would never change from 1 o'clock. Using a for loop. The for loop is a definite loop. It's a counter-based loop. But what's awesome about it is it does 3 actions in one structure. It initializes the variable, it tests it, and it alters it all in one line. So instead of taking 5 lines of code, including the end, right, it only takes 3 lines. Or if you left the comment out, what can be done in 4 lines of code can only be done in 2. And the reason why it's awesome is not just because it's shorter, but it's because you never forget to update the variable. You never forget to reset the variable. Right? My clock only went from 1 to 6 because I forgot to update something. No, I forgot to reinitialize it. Whereas if I'd done it in a for loop, I wouldn't have had to sweat it. So for example, this is using the Visual Basic syntax. Apparently they're going to use it for pseudocode as well. Initializes the count variable to 0. It keeps going up until 3. Now remember, Python would have made that 4. Updating it by 1. And as long as the counter is still less than or equal to 3, it'll print hello. So this would print hello 4 times. It would, because counter is going 0 to 3. If you count that out, 0, 1, 2, 3, that's 4. 0-based indexing rather than 1-based indexing. That's why if you leave that number off in your code, it starts at 0, like this. For x in range 10, it's going to go 0 to 9. Print parentheses x, we will see it count from 0 to 9. Now, since I'm super picky in my code, not when I'm grading, I'd let you do that, but I would have put 0, 10, 1 to make it absolutely clear where it's starting. Yes, sir. Pardon me?
Don't you have an appointment today?
I do. Need to stop. Thank you.
Right. No, I'm just like.
Yep, you're right. You saved my butt. I was going to stop in a few minutes, but I think it's a good time to stop now. We hit for loops. That's what I wanted to do. We've already seen examples of for loops and how to graph them, so I think we're good to go. We're going to count the test flowchart as your homework, so that's really going to have to be the only homework assignment you had this week since we had the exam on Monday. I'm not working y'all hard enough. I should be a slave driver. Nobody laughs at my jokes. All right. I guess you're agreeing with me. You think I'm not working you hard enough. All right, let's go ahead and stop and make a Dropbox for today.